So here I have a problem from the LSU math contest from the year 2018, and this is number 23 on that test. And it tells us to find an integer between 400 and 1000 that is divisible by both 7 and 13, whose digits add to a prime number. So I think you could do something with divisibility rules here, some tricks for 7 and 13. But the way I would go about this is just to brute force all of the different numbers that are divisible by 7 and 13 between 400 and 1000, whose digits add to a prime number. So just kind of check off the boxes as we go. So first we're going to make sure our number is constructed by 7 and 13, and then add some extra numbers in. So first I want to note that 7 times 13 is equal to 91. And these are, in fact, the only factors of 91 because 7 and 13 are both prime. So that's really helpful here. Because now we can just multiply 91 by a bunch of different numbers to get numbers between 400 and 1000. So let's make a quick chart. We're going to have 19 times n right here and n over here. And anything less than 5 for a value of n gives us something less than 400. And anything bigger than 10 gives us a value that is larger than 1000. So these are the only numbers that we're going to have to work with here. 5, 6, 7, 8, 9, and 10. Okay, great. So let's go ahead and calculate these out, and I'll fill in the rest of the chart. All right, so now that we've got the chart filled in, these are the only numbers between 400 and 1000 that are also divisible by 91, which satisfies our 13 and 7 condition up there. Now, the only condition that we have left to satisfy is this number's digits adding to a prime number. So let's go ahead and add the digits of all of these numbers. 4 plus 5 plus 5 gives us 14, so that's not a solution. 5 plus 4 plus 6 is 15, that's also not a solution. 637 gives us 16, that's also not a solution. 7, 2, and 8 gives us 17, and 17 is a prime number. So this is a solution to our problem. And let's go ahead and keep going and check these last two. 8, 19 will give us 18 here. That's clearly not a solution because 18 is not a prime number. And 9, 10 gives us 10 here, but this is also not a solution. So our only solution to this problem is the integer 728. And how did we get there? Well, we first imposed this condition that this number be a multiple of 91, because that satisfies having both 7 and 13 as factors. But then we also imposed that the digits added to a prime number with this chart right here. That's enough for now.